Hello everyone. Can you just confirm that I am audible? You are able to see my screen and even quickly, so we can start the session. Okay.
Yes, because you are audible.
Okay. Thank you. Okay, guys. So welcome back to the series of NLP, and I hope everyone is doing fine. And let us get started then. Okay. So we started discussing about the NLP. What is NLP? How computer can understand NLP? What are the challenges in the NLP? And how we can make our data ready for the usage or to be absorbed by the models or by the NLP models, right? So having said that, we also started with understanding that what will be the first step. Okay, whenever we are trying to understand NLP, what will be the first step, how we can make a text pre-processing, right? That's what we understand, that this will be the first step. Okay, whenever we want to deal with the data, whenever we want to build any use case or solve use case, what we have to do is first we have to understand with the text processing how we can pre-process the text so it can be ready, and then we'll be able to take the text analytics, right? Text analytics, that's our main agenda, right? And whenever we are talking about NLP, it's all have to do with the sequential data or maybe with the text data mostly, right? So that's what we are speaking about. So having said that, we started with understanding the basic concept, like how, if I am getting a chunk of the data, right? If I am getting a chunk of the data, a huge data, how I can consume it, what are the first challenges with the data, how I can start analyzing the data, what are the steps, right? And in that step, we started understanding that whenever we get a data, then we start with the first thing, that will be tokenization, right? Tokenization was the first step where we start and we try to understand that what are the different tokenization methods available. So, and then we'll start continuing with the stop words. We also understood what is the stop words, how we can remove the punctuation marks, how we can clean our data, right? How we can clean our data so it can be consumed further and we can make it usable. So we were able to discuss till the stop words, and we started with an introduction of the stemming. And then we wanted to continue with the same agenda today: stemming, lemmatization, word vector, TF-IDF. And these, once we are done with these things, then our text pre-processing will be finished. And then we'll try to understand that how we can perform the analytics out of it, right? Out of this data, analytics on this data. That's the agenda, guys. So today we're going to discuss a real-time use case. So I hope you guys will enjoy this session. Today's session going to be very special because what we'll do is, I told you guys that I would try to come up with a very good use case where you guys will be able to relate it to real-time world. So today we'll try to understand how we can make a movie sentiment analysis. Movie sentiment analysis. I'll make a code walkthrough for the same. And for that purpose, we have meticulously taken the data for the Adi Purush movie, which was recently released, Adi Purush movie. And we'll be becoming the critics today. So we'll try to understand, and all the data has been collected. It's first of all, guys, this is not the project I have done. Some of my colleagues have done this project, and it was very popular few months back. Whenever this movie was released, this project became very popular, and it was one of the real-time on good use case where you will be able to apply all the concept, all the text pre-processing concept, all the text analytics concept, whatever concept you are going to understand, and all this concept will be applied over here. So it's going to be very exciting today. So we will be doing a real-time analysis of this movie, and all this data has been collected from the Twitter, guys. Okay, all the tweets has been around let's say more than 10,000 tweets has been collected, and on the basis of that, we'll try to understand how we can clean the data, how we can bring it to the desired format, and how we can apply the further algorithm and try to understand the sentiment or the reviews. Okay, we'll try to understand the reviews for the same. I hope and then also followed by, like I promised you guys, that we will be doing a real-time project. So we'll also try to have a look at the sentiment analysis. Okay, on for the courses, sentiment analysis for the courses applied by the engineering college, right? This is also one real-time project which has been which was become very popular, and we'll try to understand. I will make an entire code walkthrough, guys, very quickly, so you can implement the same project for your respective colleges and for your respective places. Okay, it's going to be super exciting today. So without wasting time, let's get started. Guys, please ping me if you have any questions. Okay, so I'll be able to take it from there. I won't be unmuting anyone as of now. Okay. So if you have any queries or any questions, so maybe you just quickly ping me. I will take it simultaneously. So let me share my notebook, guys. Having said that, I'll share my notebook and we start continue this discussion wherever we left yesterday. Okay. I hope everyone is able to see my screen. This guys quickly ping me if you are able to see my screen. Right. Okay, thank you, guys. Okay, let's get started then. Yesterday we discussed about the tokenization. Let's get started ahead of it. So tokenization, everyone understood that whenever we are using any tokenization method, right? Tokenization means there will be two types of tokenization. One is sentence tokenization and another one will be word tokenization, right? Word tokenization. Whenever we are using a paragraph, this kind of a paragraph, then what we'll be doing is first thing or foremost thing, even before we go into all this concept, our main aim is to, right, to make this text in a readable format for my model, right? For my model or algorithm. So how I can do it, right? Because this is a text and my model understands only numbers, right? 0, 1, 0, 1, something like that. So that was my main aim. And in an order to make this possible, we have to apply some kind of text pre-processing. And for that text pre-processing, we understood that with the simple way how I can convert this text into number is using the different words which are present, right, in my paragraph. Let's say this is my paragraph or this is my entire corpus of the data, and whatever data I am having, I will be try to break them into the either sentences or into the single words, and then I will be able to convert them into some sort of numbers, right? That's our main aim. Try to understand that our why we are doing all this pain or why we need this entire text processing is because we just readily cannot go ahead and apply our machine learning algorithm or deep learning algorithm on this data, right? We have to bring it to a vector form and some sort of numerical form, right? Or word to vector. This is our desire, that why we want to process all these data, right? I hope this sets the context that why we are doing this, and this will be one of the most important step whenever we are learning the NLP, right? So we understood tokenization. Tokenization is like breaking down entire para or entire corpus into the different sentences or either into the different words, and this is how it will look like, right? And but the problem with the tokenization, we also understood that with the tokenization we will be able to get some certain words or some certain punctuation marks and some other series of the alphabets and letters which will not be required, right, in real time when we try to do a analytics text analysis. For that purpose, we understood that what we can do is first step, like there was a very good example, people you guys suggested that whatever sentences or whatever words we are having or entire corpus which we are having, we first thing we should do is to try to bring them to a similar case, right? Because yesterday a day before yesterday, sorry, we seen the example that even after removing the stop words, right? Even before removing of the stop words, there was it present in it, which is actually a stop word, and in my stop words, it was showing in the lower case, right? So that was the problem. That's why, since this is a case sensitive, always we try to bring it to a lower case or uppercase. Okay, that's what we will be doing in first step. And once we do that, then we'll go going for the tokenization. Once we tokenize that, again, that will be problem. Like we understood that whatever token is there or whatever data is there, right? I still don't require all of the data in order to analyze or set a context behind it, right? So for that purpose, we understood the concept. I will go back to this POS tagging and chunking, guys. First of all, we try to discuss what is stop words. We also discussed it yesterday itself, but I will again go through it. The stop words helps us or plays a very important role. So using which we'll be able to remove the unnecessary words. Even after removing the words, like you can see here, the stop words from an NLTK corpus, we have imported a stop words, and that too for the English language. And I can see these words like I, me, you, myself, your, yourself, right? She, them, having, been, during, fetch, and all list of this kind of words. Even if I remove this kind of words, I will be still able to understand the context, right? I will be able to understand the context, or let's say the intent. I will be able to understand the intent behind the speech, right? And understand the context behind the speech, right? Even though if I remove this kind of words, it will be still giving me some sort of idea that what I am looking for, what are the commands that a human is trying to execute over here, right? What is that we are trying to execute over here? So that's the main idea. And also we saw that if I am directly without removing these stop words, right? Without removing these stop words, let's say I got like 10,000 words, right? So in order to convert them, I will have a dictionary, right? I will have a dictionary or a vector which will be having like 1 to 10,000, right? 1 to 10,000 indexes, and for each and every word there will be one index set. For let's say Vikas, there will be index at 1, or let's say for Bharat, there will be index at certain location, let's say 500 location, and so on. And it will become again a very huge, and let's try to understand that in terms of the computation, from competition or scalability point of view, it will become very difficult to deal with this kind of a situation, right? So our main aim was to reduce the dimensions, right? Reduce the dimension in such a way that without losing the significant information, right? Without losing the significant info within my corpus, right? That was my main aim. And that's why we are using this kind of packages or concept or functions which are available. So we were able to remove the stop words. And we also saw that even if I remove this punctuation marks, still I will be good to go, right? Having said that, let's move ahead and try to understand that how we executed the code. This was already discussed, that whenever I am trying to pass this data, right, at the first index, when I am using the stop words and punctuation marks, and I set up the loop, and I have just created a small list, which is a clean data. And then I am trying to loop over here. And if let's say I have taken a sentence till this much part, then first step will be India. And then we will try to understand whether India is present in the right in punctuation mark. If not, the cursor will move to the control will go to next loop, where it will try to search it within the stop words. If it is not, then it will get appended to our clean data. And similarly, things will happen. And whenever this kind of things will come in, punctuation marks or some other stop words like the D, of, A, in, right? All this will be getting removed, and we will be ending up with the clean data, right? Then next step will be like this is the clean data now, but this was the challenge which we saw, because we did not convert it to lowercase. Even this it was present, so it was able to capture it even after removing the stop word. So it is always better to convert them into the similar cases, right? Okay, then once our data looks good, right, guys, again just a request that if you will be able to raise the hand, I will not be able to unmute you. So if you have any query or any questions, any suggestions, guys, please ping me in the chat box. I will try to understand it. Okay, all right, guys. And then the next step now, even after removing the clean words, right, the next step was to how we can further go ahead and remove the unnecessary things or unnecessary columns, or how we still try to bring our data to a less dimensions, right? Bring our data to the less dimension. And that was the main aim for us. And that's how these concepts comes into the picture, stemming and the lemmatization, right? In stemming, we understood that even in the class of the botany, right? We understood everyone that whatever plants are there, even if we use the stem of their plants, and it will be able to grow out of the stem as well. And the same concept has been applied over here in the NLP, that we are trying to find the stem of the corpus, or we're trying to find the stem of the words. And maybe if I have this kind of words, let's say running, runs, and ran, all these words will be brought to its basic form. Okay, this basic form, and which is again the original verb is like run. Okay, original verb is run, and that is called as stemming. Even for the stemming, there are different packages available. You can say functions available. One is snowball stemming. There is one more stemming, Lancaster stemming, and then there are other stemmers. How they work is somewhat different. Internally, their use cases is different. That is not making a much difference, but still you need to understand that stemming. What is stemming is doing is trying to bring down the words, or whatever words we are having, into its basic form. But again, guys, like I told you, for this example, like we are taking running, right, runs, and ran. All these three words were, right, all these three words were brought into a single dimension, that is run. Now try to understand that what could be the challenges with the stemming, right? What could be the challenges with the stemming? That's why the lemmatization thing coming into the picture, or why we need sometimes the lemmatization. So try to understand that. This is also a very good concept. That let's say that in my database or in my words, let's say this kind of word is present. Let me write this. Okay, this is computer. Okay, then there is another word present, which is computation, and there will be a third word present, let's say, called as computes. Okay, computes. If I try to and what is the work of this stemming? To bring all this data to its base form, right? To its base form. For running, runs, and ran, it was almost same. If I cut down all these prefixes or some suffixes, and I am trying to bring it to its original form, that is run, still I will be able to find out some info, or I will be able to find out the information, or let's say we will be able to get a feeling or background about this word, and it will be making some sort of sense, still some sort of sense, that all this action has to do with run, right? All actions or whatever context we are trying to set over here is related to running, right? Run, or the action of run. But in case if we get this kind of situation where we are having a different word, right? Computer, computation, and computes. What stemming will do, if I apply stemming over here, then stemming will try to bring them to its base form as a compute, right? COMPUTE, compute. Okay, compute. So now this is the challenge for us, right? Because computer means something else, computation is meaning something else, and compute is giving me some sort of different information, right? Different information I'm trying to achieve through these words. And if I simply go ahead and apply this stemming, I will be able to end up with the compute word. And this is losing the context, or this is losing my entire speech, right? Speech goal, right? Speech goal, that what I am trying to convey, or whatever message I am trying to convey, will be lost if I directly go ahead and simply apply the stemming over here. So for that purpose, stemming, without understanding any meaning, right? Without understanding any meaning, it is trying to bring down the word to its base form, right? Its base form. And in fact, using this, we are having certain issue with it. And that's how the lemmatization technique comes into picture. What does this lemmatization do? Again, the same thing. If we are having this kind of situation where we are using this kind of words, let's say compute, computation, and computer, it will try to not to bring them into compute form. It will try to understand the context. It will try to go back and check the meaning, or let's say it is programmed in such a way that this technique, that it will try to understand the meaning or word meaning, or let's say intention behind it, or whatever action it is trying to denote, right? And then it will try to convert. That is the basic difference, guys, between stemming and lemmatization. Okay, so that's why sometimes we need a lemmatization technique rather than using stemming. Okay, all right. But having said that, my next question is for you guys, try to understand that we understood what is stemming, what is lemmatization, and both are doing the same task as bringing down the dimension, right? Higher dimension to a lower dimension, right? But stemming is not looking at the meaning of the words, whereas the lemmatization is looking at the words and trying to bring down the words, right? That's the basic difference. Then which one is better, guys? My question is, which one is better? Can anyone quickly tell me that which technique will be better, whether we should go for stemming or whether we should go for lemmatization? That's the next question that comes to our mind, that which one we should apply then. Okay, can you guys quickly tell me that which one should we be applying? I have understood what is stemming, what is lemmatization then, and my whole aim or entire aim is to bring down the higher dimension data into lower dimension data, so I can perform a computation or scalability at very fast level, and then I to understand the concept and make the analysis, right? Text analytics. So can you guys just quickly tell me or ping me that which technique should be better, right? Stemming or lemmatization? Guys, quickly ping me. So on the basis of this difference, just try to suggest me that which technique should we be using in the real time whenever we're trying to perform the analytics. Anyone, guys? Anyone would like to ping? Okay, Venkat is saying stemming, but I think stemming. Okay, Teresa is saying lemmatization. Namdev is saying stemming. Okay, now 2 votes for stemming, guys, and 1 vote for lemmatization. Kapil is saying lemmatization, lemma. Yeah, but guys, also try to give me a logic that why you're thinking, right? Is it because of the word stemming? Why stemming and why lemmatization? Can anyone quickly tell me what is the supporting hypothesis behind this, right? Choice. Can you just guys tell me quickly what is the hypothesis that you guys are suggesting me to go for lemmatization, go for stemming? Just guys quickly ping me, so because it gives a real base word. Okay, yeah, correct, Preeti. It gives a basic words. So Kapil is saying stemming is not having meaning. It's a brutal way. Okay, okay, guys, understood. Anyone else would like to tell me anything? Quickly, guys, so I can go ahead then and tell you that which one will be used. So now we are setting up the context over here that I should be using lemmatization, right, rather than stemming, because it's a brutal way. It is without looking the meaning, it is try to shorten the things, right? So anyone having any other thoughts, guys, apart from it? So anyone quickly ping me within seconds, just quickly ping me, so I will be able to tell you then what we'll be using in real time. Anyone else, guys? Quickly, any other opinion? All right. All right, all right. Okay, guys. So let's try to understand that which one we'll be using. That's an interesting question now. But I would say that even the stemming is a brutal way, right? Correct. It's a brutal way. It's a brutal way. And without looking for the meaning, right? Without looking for the meaning, it is trying to cut down the dimensions, right? It is trying to cut down the dimension. But in reality, whenever you will go for this kind of techniques where we want to shorten the things, still people will be going with the stemming. Now you'll ask why. Okay. So, but still, the stemming is the best method, I will say. Stemming is the best method. Try and understand why stemming is the best method. Because if I apply lemmatization, guys, try and understand what it's doing. It is going into the corpus, right? In going into the corpus, it is trying to find the synonyms or some meanings for the words, right? Word meanings. Word meaning. And then after understanding or analyzing the meaning, right? Performing this comparative analysis, right? And then it is trying to cut it down, right? Then it is trying to cut down. But in fact, remember or try to understand that whenever I am trying to apply this kind of process, right? It is a lengthy process, first of all. It's a lengthy process and it will take much more computation in real time. It will take much more computation in the real time, because I will not be having, let's imagine that you are having 1 million words in your corpus and you want to analyze this data in real time, right? In real time, then what you will be doing, right? What you will be doing if you having this kind of a huge data set which is consist of millions of words, right? At that time, if you start applying the lemmatization, it will go crazy, because for each and every word, to find the meaning and then coming back and then trying to understand whether to cut down or not, it will be taking too much time. So we always go for stemming, even though without looking without looking at the meaning, it trying to cut down the words. Maybe it is possible that when I am trying to loop through this entire form of the sentences, or let's say entire corpuses, maybe some words may lose a intent, some words may lose some sort of meaning, but that could be again connected to some or sequenced with some other next words, right? And by end of it, when I'm trying to summarize the things, end of it, when I'm trying to summarize the things, right? At the summarization technique, it will be taken care, whatever the information might have lost at a certain point of time, right? So that's why we always go for the stemming, because it is the fastest way and it will help us to bring down the dimensions. Okay, let's understand that there are, like I told you, for the stemming also, there are Porter stemmer, Lancaster stemmer, and Snowball stemmer, right? These are the three different packages, and then by using it, you will be able to bring down the different words. Let's say this, imagine this, if you are using Snowball, it will be using hobby as hobby, again hobbies as hobby, but computer and computation as compute, and compute. Okay, that's how. And even if it is making I for Y, hobby and hobbies, right? It is trying to bring down. If you can look at it, for these two words, it is bringing this word same. But if you use a Lancaster, then it is trying to bring out as a hobby, HOBBY, is rather than using I, right? So this is a basic difference, some sort of difference. But again, in the end of the day, it will be doing the same thing. So no need to go back and discuss. Just for the information purpose, I have put in it, right? Lancaster, Snowball, and Porter. These are the ways, right? Now, next thing is to perform the lemmatization, right? Lemma. Lemma is the basic word to bringing back to the original word. That base word is lemma, right? It is any specific language word. So on the basis of that, they have adopted this lemmatization technique. Okay. So whenever I am trying to apply lemmatization now, try to understand, guys, this is very important concept, that when I am trying to take this word running, runs, and ran, and then I applied lemma.lemmatization, right? Still nothing, right? You can see here, it is still giving me the same thing, right? It does not perform any lemmatization on it. So why? What could be the reason, right? The reason is, like, we have to do a POS tagging. Now the POS tagging comes into the picture, guys. Okay, POS tagging comes into the picture. That's why I did not cover it earlier. Now you'll be able to understand or connect the dots, that why POS tagging, what is POS tagging. POS is like part of speech, right? Part of speech, and by looking at the part of speech, we'll be able to bring down the word to its normal form. Okay, try and understand how it will be doing. If I look at this code, right? If I look at this code, so earlier I did not provide any POS tagging. Now, when I am saying running, I am also providing the tagging that it is a verb. Okay, run, it is also verb, and ran, it is also verb. Okay, it is a verb. It is also verb. I am giving a tagging of POS, part of speech tagging, and then it performs the things, right? Perform the things. So that means what? Whenever we try to perform the lemmatization, at that time I have to also give a POS tag to it, right? And then once I able to provide the POS tag, then we'll be able to cut down the things to its basic form. But again, this thing of doing a POS tagging has been done manually over here, right? I've done these things manually. What if I have a 1 million words? Then what the use, or in real time when I am trying to loop through the sentences or loop through the words, right? To entire corpus of the words, then how we will be able to achieve these things, guys? That's the question, right? Writing POS is impossible for corpus, correct, guys? So that's the next question, right? So that is impossible in runtime. Even for runtime, if whenever I am trying to loop through the word or sentences, performing POS tagging will be difficult, right? So that's how the NLTK comes into the picture. NLTK library comes into the picture, and they are having a concept called as POS tagging, which will be able to help us to perform this kind of tagging. Okay, so let's try to understand that. And before even we go into these things, guys, let me tell you, Can anyone quickly ping me that how many part of speech are there? How many part of speech are there in English language? Right, to understand this is very important concept. So why I'm asking these things, you will come to know. This Sanjeevani is saying 8. Correct, guys. Anyone else? 8 is fixed, or are there any more than that? How many part of speech are there, guys? Quickly ping me so I can go ahead and tell you guys that how POS tagging works. Many but basics are VBPN. Verbs, pronoun, correct. Many but there should be some number, right, Bina? There should be number, right? What could be the number? What is the maximum part of speech? Teresa is saying yes, yes, it is 8. Yeah, guys, it is 8, right? But from NLTK point of view, try to understand from NLTK point of view, there are more than 8. Okay, more than 8 POS tagging part of speech. Now you will understand that why more than 8 or 9, right? More than 8. Say, let's take example. When I'm talking about noun, yeah, in English, we don't have this kind of bifurcation where I will be saying that for noun singular and noun plural, right? But in POS tagging in the NLTK, they have made a bifurcation in order to make it more convenient for the machine to understand that NN stands for singular, then NNS stands for plural. And similarly, for proper noun singular and proper noun plural, they are having this kind of bifurcation. So that's why we're having more than 8 part of speech. There are many other, it will not go into detail, but our main aim is to understand that how this POS tagging will work, right? And why we need a POS tagging, we understood. Whenever we want to perform the lemmatization, that time I have to do a POS tagging. So for that purpose, let's say we're taking this example, we will see an example of POS tagging. POS tagging equal to NLTK dot PS tag underscore POS tag. Okay, this is the function. And then you have to tokenize. Just I am trying to break this sentence into the words, right? And that's how the result will come in. It is taking V as proper PRP, proper noun, then will as MD, C as VB, verb, right? Noun, and then NNP, proper noun, singular, right? And singular noun, this way. Okay, guys. So this is how it will be able to do it. So you don't have to go and do it manually. It will be doing a POS tagging on its own. And you just have to make sure that you are doing this kind of tagging on the runtime. So it will be able to perform the lemmatization. All right. And then once we understand what is lemmatization, guys, then the next concept is very important, that sometimes we have to perform the chunking also, right? Chunking is nothing but like it's a collection of the words or data, right? And in chunking, what will happen, I will tell you. In chunking, or let's say in parsing, it's a very word that whenever you turn to perform the parsing, parsing is nothing but, guys, again try to understand our parsers. There are different parsers available. Okay? We seen stemming, we seen lemmatization, and then when the concept of the parsing comes into the picture, that means we are trying to perform our own grammatical rules. Okay, on the basis of own grammatical rule or custom grammar, right? You can understand that we are trying to perform some custom grammar. On the basis of that custom grammar, we will be doing a POS tagging, right? So that is how the parsing or the chunking comes into the pictures. Let's try to understand that what this concept means. Okay, let's say that we have seen that in POS tagging we have a normal tagging like NN, NNS, NP, NPS, right? For singular plural, there are different ones. Noun, pronoun, right? Noun, proper noun. And then what if I want to make some sort of other rules as per my use case, that using that I will be able to make some kind of own custom grammar, right? On custom grammar. So let's take a same example and try to understand that. What I can do is I am trying to create my node equal to MN, and within my node, this is the tag I am trying to create, guys. Try to understand. So I'm trying to create this kind of tag, and this tag will be consist of the NNP and NN both. Okay, and that's how I will be able to do the custom grammar. So first, what I have to do is whatever already POS tags are there, for that POS tag, maybe you try to group them into your own custom groups, or you try to create a different custom POS tag, right? Custom POS tag. That's what the parsing and chunking means here. And then try understand, this is example where I'm trying to collect or combine this NNP and NN as an MN, and then using the regular parser, I'm trying to pass these things to the chunks, and then chunk dot parser equal to POS, that's my node, right? And then once I able to perform this, this is how it will be looking. See, and if we look at the things, this sentence is now V is proper noun, will is MD, C is VB, but MN, it is showing NN as MN and also NNP and NN as MN, right? Because I created my node and my node consists of all this NN and NNP, right? So that's how it will be able to show you, right? Your own custom grammar rule. But guys, I understand this again is very, let's say, complex process. This is not the usual process what we'll be doing. Sometimes you require some kind of customization, right? In terms of the data. At that time, this parsing and all your custom POS tagging will be coming into the picture. Otherwise, for the regular sentiment analysis and for the regular use cases, we will not be doing this kind of things. Okay, this is again some sort of advanced things, and we will not have to do these things. And again, but whenever in terms of the NLTK, right? NLTK is the library which we are using, Natural Language Toolkit. So for that purpose, you have to provide these POS tags. But if you are using a different library, let's say Spacey, at that time, you don't have to provide this POS tagging. It will take care in the background. Okay. All right. So let's, having said that, let's move to next step. Then once we are able to perform stemming and lemmatization, guys, still I have not, even after performing these things, whatever data is there, still we were not able to convert that data, right? We're still having the text data itself, right? But my main aim is to convert this data into the proper format where I will be able to perform the vectors, right? And then one more concept is, guys, there, name entity recognition. Like I told you, whenever we are doing this kind of parsing and all, right? These parsers or chunking where we are creating our custom grammar rule. So at that time, if you could remember, guys, we have created the chart boards, and using this chart boards, always whenever we are trying to pass any command, right? Let's say hi, hello, or something like that. And whenever I'm trying to pass these things, it is trying to understand your intent, right? It trying to understand your intent. And let's say if I'm saying greetings, greeting is your intent. After greetings, if I am asking for, let's say, any weather condition, at that time, it is trying to understand weather condition. Along with the weather condition, I'm asking what is the weather in the Bangalore, okay? What is the weather in the Bangalore? So it understands that this Bangalore, this word has an entity, right? It is an entity which belongs to the GeoCity. Belongs to the GeoCity, right? It is a city. It is a city, and weather is my different intent, that I am trying to understand the intent of the weather. And for this weather, I am trying to understand what is the entity. Entity is Bangalore. That means I am talking about the city. So this kind of bifurcation, right? That or all that bifurcation of this kind of things is called named entity recognition. Okay, this is the concept of the name entity recognition. So why I need these things? Because whenever I'm trying to create any conversational AI, right? Conversational AI. In conversational AI, if I'm trying to make these bots work like the humans, or make them to understand or execute our command in the natural languages, at that time, I need to understand that what I'm talking about, which entity I am talking about, what is my intent, and what is my fulfillment. Okay, what will be my fulfillment for that intent? Let's say my intent is to greet first, and after greeting, I am talking about the weather. And then obviously for the weather, I need to have a city, because without talking about the place or the city, it doesn't make any sense to give you weather on a specific manner. And once I am able to give you this kind of city or weather as an entity, then I will be able to fulfill you with the current, let's say, max temperature, mean temperature, or wind speed, or some sort of humidity condition, right? This kind of information I will be able to provide it. And for that reason, we need to understand this concept of the name entity recognition, right? So whenever I am trying to perform this, again, it is same. First, we'll be doing a POS tagging and then chunking, and then we can show the named entities, right? Name entities, let's take the example of this graphical representation. We will be able to see that the India is showing geographical location. Also, Republic, it understand that as an organization. Okay, again, India is also geographical location, and South is a direction, and Asia is also a region, right? Is a region. So that's how you'll be able to understand or make it it will be able to make a sense out of it, right? Which entity, right? which entity denotes what. That's how it will start making sense, and it will be able to understand your context, right? That's the main things. That's why we require this kind of name entity recognition. This also example, if say organization has Georgia Pacific Corporation, WHO, persons like President Obama, right? Location as Murray River, Mount Everest, date and time, even money, percent, faculty, all these things are already there in LTK, and that is called as name entity recognition. So this is very super important concept, guys, because even without name entity recognition, there will be no accuracy in understanding the request, right? Parsing, we already talked about recursive parsing and all. This kind of custom grammar rule, you will be able to analyze, and you will be able to make a differentiation between the words and which word is important, which is not important. That's the main reason. And again, I'm still left with the words, and then next concept comes to word vectorization, right? In word vectorization, I told you guys that the whatever my text data is there, I need to convert them into the vector, right? In such a vector, so it's a consist of the numerical vector, let's say from 999, and in the basis of that, the model will be able to consume it. So what are the methods for the word embedding? That is very important. The concept will remain same, whether it will be deep learning, whether it is machine learning, or any advanced algorithm or large language model, right? All the basic concept will be same. That's why we're trying to understand this. So let's finish this one fast, so we can move to our project walkthrough. Okay. So word embedding. In word embedding, what is the best way to convert the word, right? So best way, or can you guys, based on our ML knowledge, right? Based on our machine learning language or deep learning knowledge, right? Preprocessing knowledge, which we already having. So can anyone tell me that what will be the best way to convert the text into numbers? Best way to convert the text into the numbers. Any algorithm, any idea, any concept you guys can tell me, right? So we can discuss over it, and what could be right or could be wrong, and how it will be difficult, or what could be the challenges in NLP, that how we will not be able to understand this concept. Can anyone tell me that how I can convert a text into numbers, right, guys? Bag of words is there, right? Correct, bag of words. What else technique is there, guys? How we convert the text into the numbers, right? In machine learning, basic machine learning, what we do, we are having some kind of concept where even whenever I try to build a machine learning model, whatever text data I am having, let it be a classification algorithm or something, right? Correct. So one hot encoding, correct, label encoding. Now try to understand that why in traditional machine learning algorithms will not be able to help us in the NLP. This kind of concept, right? In NLP, why it is not possible, or what could be the way, difficult way in implementing. Guys, this is very important that we understand what are the challenges. What are the challenges in implementing the text to numbers, right? Once we understand these challenges, then we'll be able to understand that which techniques to apply, and which technique will work and which technique won't work, right? That's why we need to understand from very basic point of view. If I am using any label encoder, this is the best thing we can use in machine learning, that label encoder, or I can get one hot encoding, right? One hot encoding. These are the two ways which are available in machine learning concept. In label, in one hot encoding, what I am trying to do is I am trying to convert everything into 0 and 1s, right? In 0 and 1s. But imagine that if I am having this kind of words, let's say, what you can say, the food. Let's say we are trying to perform a review analysis for any restaurant or any kind of chef. The food is good. Food is good. I liked it. I like the food. I like the food, and the service is also good. Okay? Service is also good. So in this case, if you understand that good has come 2 times, okay, 2 times it has appeared. The food is an important word. Then I like is also important. Like and good is important, but food is I. Service again is not important. Those are the stop words I'm trying to understand. I can remove stop words. I can remove punctuation marks. I can use the stemming. I can bring down to the clean data, right? Now I am having this clean data, and on the basis of that, what I can do is my last step will be to convert it to a vector, right? to convert this everything into the vector. And I understood that when I do a one-hot encoding, right? One-hot encoding, at that time, either I will be converting it to zeros or ones, right? Zeros and ones. And if I am trying to convert these words like I liked it, like, good, and better or efficient service, this kind of words, either it will be showing 0 or 1 for them, right? But where is the context or where is the stress on these syllables, right? Or where is the stress on these words, by using which I will be able to bifurcate them using positive or negative, right? If that words is coming 2 times or 3 times, it's okay. Okay, I can understand that it's got the importance. It got the important, but that when I'm trying to understand the frequency, at that time it will come into the picture. But when I am using one-hot encoding, and let's say for that purpose, if I'm using the label encoder, again the same issue will coming into picture, that whatever label encoder is there, let's say I am having 1,000 words. So to try to convert one word from 0 index to 999. And then what my model will understand internally is whatever word, let's say the word which has came, and maybe the word which has came was Vikas at this index of 999, and this word which says like came at the index of 0. So it will understand that Vikas is more 999 times more important than light, which is not the reality, right? Which is not the reality. That's why we'll not be going with this traditional approach. We need some sort of different understanding, how we can make this concept more clear to our model, how we can stress on the important words, right? And that's why this word vectorization concept came into the picture. And they understood that what I can do is I can count the words. Okay, count the frequency of the words, and on the basis of the frequency, if any word, let's say light for that purpose or good, coming more frequently, that means it is important, right? So I can understand that this is giving me a positive vibes, right? Positive vibes out of this entire sentences or entire views, right? That could be the possibility. So that's why they came up with a concept called as count vectorization or bag of word model. Now try to understand what is bag of word model, but let me tell you very honestly that nowadays people are not using this bag of word model or n-gram model. But still, I would like to discuss these words because it is very important that understand that what is not working. If you guys understand what is not working, it will be very easy for you guys to figure out that what could work well, right? What could work well. So let's do a reverse engineering sort of things, that I understand what is bag of word or what is model, bag of word model and n-gram model. Okay, and bag of word model is nothing but trying to understand the frequency of the word. It is trying to make a tokenization. Let's say take a sentence, I went to have a coffee, but I end up with having a lunch with her, right? So at that time, I'm just trying to have a word by word understanding of each entire sentence, and I'm trying to count them, that which word appear how many times, right? And if I see that any word has appearing more times, mainly it is having a good weightage, right? I can have a good weightage for that word, and this will make me understand the intent or the concept, or let's say the feeling behind the entire sentences, right? Which will be a keyword for me, right? If it is coming more frequently, so that is called a bag of words. So what we're doing is just we're trying to do a count vector. Count vector over here. I'm using that count vector. I'm just trying to put a number against the words like I went, right? Coffee, and how many times it is appearing, 2 times, 3 times, 4 times in the entire corpus. So that's the main question. Okay, now understand what is n-gram. I hope this bag of words is clear for everyone. So understand what is n-gram. In n-gram, we are having different sort of flavors. Let's say 1 gram, 2 gram, 3 gram, right? Trigram, bigram, or let's say we also have something called as skip gram. So people, what they said initially is, okay, it is very good that you are trying to understand that how many words are coming, what frequently, and you are trying to give a stress on the frequency of the words. But where is the logic or where is the sequence, right? Where is the sequence? I'm just by using the vectorization method, right? By using the vectorization method, I am trying to use a connection, right? I am trying to use the connection between the words, right? Whatever words connection is there, let's say I went to have a coffee. If I'm trying to break them, I went, have coffee, and I'm trying to assess these words, right? Individually. If I'm trying to assess these words individually, there should be any sort of connection, right? if any connection, whenever we are speaking out any speech, right? So whenever we talk about speech, the speech words which are current at the current index is there, it has some sort of relationship, right? Some sort of relationship to its previous word. And then by using this kind of relationship, we are able to analyze the entire sentence, right? That's how the human being analyze the sentence, or that's how the human being analyze whether you're talking in sarcasm way, or whether you're giving a general feedback, or whether you are upset and you're giving any sort of negative feedback, right? Same words, but the tone, the way they are presented, or the way, or the, let's say you can understand that the way they appear, their order, right? Order of appearance, right, is very important. If any word appear in the end or any word appearing in the beginning, is giving us also a different set of tone, right? Set of tone. For that purpose, this said that let's not go with this only frequency concept. Also try to go with the concept of the this anagram models, where instead of taking one word at a time, I will take a 2 words at a time, 3 words at a time, and then I will try to take a frequency out of it. And then I will be able to analyze that, okay, if I went or I liked or I ended up, if this is appearing more times, maybe this is making some sort of sense, right? And it is trying to convey a message out of it. And also this is called concept called a skip gram. So in skip gram, let's take example 1 skip and 2 gram. Then what it will do, it will say that I don't. So gram is 2, right? I don't. Then when I try to take I don't, okay, but it is also 1 skip. So one first word at 0th index is I, and then second has to be skip, and then 2 gram. That's why I understand. Okay, that's how it will happen. Again, if I take the next word, don't understand, then it is a 2 gram, but don't understand, it also have a 1 skip. So rather than don't understand, it will become don't what, right? Don't what. So that's how the skip gram will become. So why again the skip gram? It is because of the same thing. If I try to skip some words, right? Try to skip, if I am taking in sequence, right? I'm trying to take in sequence also, sometimes it will fail because I'm trying to break them again. But what if my sentences, they works very well in the ratio of the 3 grams or ratio of the 4 grams? This I don't know, right? I have to understand this dynamically, right? I cannot have a fixed encoding for that. For that purpose, this skip gram came into picture. All right. So let's try to move ahead and try to understand a very important concept called as TF-IDF. Okay. Term frequency and inverse document frequency. This is the concept, and this is as of now used in basic machine learning algorithms. Here, IDF, where you're trying to convert them into the forms of vector, right? So this is the important concept. Nowadays, in basic algorithm or text analytics, people use the TF-IDF concept. TF-IDF concept is understood by this way. Whenever we are trying to make a columns of the words, let's say I don't understand or liked the food. Okay, this way we are trying to understand their frequency, okay, term frequency, and we are also trying to understand the inverse document frequency. And on the basis of that, we are trying to create the weightages for them. Okay, term frequency is the final score will be consisting of term frequency into inverse document frequency. So these both multiplication will give us a number or a weightage. That weights will be accordingly taken into the picture, and then we'll be able to understand the things. Understand the term frequency. Term frequency is really simple. Number of times word appear in the document, right? Number of times word appeared divided by total word. That is the simple word frequency. Okay. And inverse document frequency is also log of, like, total number of documents, and then how many times the word appear in that document. It's a, we are taking the log. Let's try and understand how it look like. Okay, TF-IDF score. Let's take example. There are 3 documents. Doc 1 consists of, this is an example. We will see how it works. IDF can be confusing. So I am trying to take first word, this. Okay. And we'll try to calculate the term frequency, inverse document frequency for the same. Okay. So I will first calculate the term frequency for this. Now term frequency is, let's say, how many times this appeared, right? One times. This is appearing only one time, right? Then out of how many documents, or out of all the documents, let's say I'm just going for one document level as of now. In IDF, I will be considering all the documents. If I am taking only one document, in that one document, I am having 4 words, right? 4 words. And of that, first word or the index word is this. This appeared only one times into this entire sentence, and it has having 4 words. So it is 1 by 4, right? Which is 0.25. And then when I calculate the IDF, right? So I will try to understand, looking at all the documents, how many documents I am having. 3 documents in total. Out of that 3 documents, how many times it has appeared? Only once, right? So what we are trying to do is, we understood the concept of the stop words, and some words which are coming very frequently, we're trying to penalize these words at this TF-IDF model, right? That is the basic concept or basic idea, that why we are trying to perform this TF-IDF, that whatever words which are coming very frequently, we're trying to penalize them. And then whatever, sometimes it is possible that if we do not remove stop words, or there are certain other words, so which words are coming very frequently, but they are not an important meaning, right? They are not having an important meaning. But whatever words are which are there, which is giving us an entire notation or feeling about the entire background about the speech, they are coming very less frequently. So for that purpose, we are trying to penalize the words which are coming very frequently. And for the same reason, we are using this inverse document frequency, right? Idea. Trying to understand what will be the idea for this one. So I am having total number of documents as 3. I have to take a log, and out of 3 documents, this word has come only once. Okay, this how, and it will be becoming something like around 1.59, right? And then if this word has appeared, let's say 3 times, then it will be log of 3 by 3, which is log of 1, which is again 0, right? This is again 0. So whatever I am trying to do is, if this is coming very frequently, I am trying to make it 0 or penalize it. And whatever word which is coming less frequently, I am trying to give it a chance to understand my model, right? And this way, I will be able to create this kind of table, right? Term frequency, IDF frequency for all the documents and all the words. And in reality, how it will look like, look at the code. I'll try to call a TF-IDF vectorizer, and then I will try to pass my clean data. And once I pass the clean data, right? So this is how the final thing will be appearing for me. Okay, with all the TF-IDF scores. Nice, understood. I think this is pretty much clear. If you guys are having any doubts, quickly ping me. Otherwise, I will start doing the code walkthrough for our very favorite topic, which is called as movie analysis, sentiment movie analysis for Adi Purush movie. And this is very super exciting, guys, because try to understand that we will be having all the challenges. Guys, please ping me if you have any doubts. So I will not be able to unmute you guys. Please ping me. I will take up the questions immediately. For a moment or two, I'll try to dedicate this moment for your question and answer. If you guys feel that you don't have any questions at this moment, so I can directly switch to the project walkthrough. All right, guys, go ahead, quickly ping me if you have any questions. All right. Guys, please be quick because we have to cover entire code walkthrough. This is super important concept. Okay. Can you explain IDF again? Okay, guys. Okay. For NLTK. Can you please tell us the working of word to wake? Okay. Okay, guys. I'll quickly try to finish these things. I understand, but this is not the end of the concept, guys. Even when we try to understand the next concept in deep learning as well, at that time also we'll be doing this kind of concepts, right? What to wake, what to word embedding, and all these things. Try to understand what is term frequency. First question, term frequency and IDF frequency, and I'll try to calculate it again. I'll try to show you what is the main aim here over here is we have to calculate 2 concepts in TF-IDF We have to understand two concepts. One is term frequency, one is IDF frequency or inverse document frequency. Okay, why we are trying to understand that, what is the concept, that why we are trying to achieve this kind of term frequency or IDF inverse document frequency. Why not I'm trying to go with the only frequency? That's the main reason. Let's say that whatever corpus or whatever data I am having, in that data there may be a thing that, let's assume that I went for coffee and I ended up with dinner or lunch. Okay, lunch, right? In this thing, I is coming very frequently, right? I went, ended. If let's imagine this is only two sentences, if this could have been very longer sentences, the unnecessary words are coming very frequently. Even though I know you guys will say that why not to use the stop words and remove them. Even after removing the stop words, at that time there will be certain sentences or words, certain words which will be coming very frequently and which are having high frequencies, but that's not giving me the entire emotions, or the, let's say, it is not giving me the entire feeling about the situation, right? About the situation. But but if I am talking about, if I want to, I went for coffee and ended up with the lunch or dinner, and then I am saying that it was nice, or it was beautiful, or let's say it was very, or you can say I enjoyed. Enjoyed came how many times? Only once, right? But all other sentences came. If I am saying enjoyed, that word, entire word is giving me a notation for the dinner or lunch or for coffee, that it is very good. This is on the positive scale, right? But if I try to analyze other words, maybe they are neutral. They are neutral or not giving me the vibe whether I should go for positive or negative, right? Even if I try to take the probability, right, for that purpose, if I am trying to take a probability, still I will be end up with something like some score between 0.5 to 0.6, and I'll be not able to understand the feelings. So for that purpose, they decided that whatever words coming very frequently, we'll try to penalize them, and that's why they came up with this kind of concept, which is called as term frequency inverse document frequency, right? In term frequency and inverse document frequency, very simple. First, we can calculate the term frequency, which is like, let's take the same example. In that document, how many times this word is appearing? That's it. In the total word are 4. Out of that, this came only once. So 1 divided by 4 is equal to 0.25, right? This is term frequency. Okay. And for inverse document frequency, what I have to do is inverse document frequency. Now I have to consider not only single document, I have to consider all the documents. So how many documents are having? 3 documents. Out of this entire 3 document, I will try to search for all the words, and within that all the words, how many times this is appearing? This is an example. We will see how it works. IDF can be confusing. So it appeared only once, right? So rather than taking like normal ratio, I am trying to inverse the ratio. Okay, I am trying to inverse the ratio. Rather than taking like how many times appeared divided by number of documents, I am saying in numerator, I am taking how many documents are there. Number of docs, right? Number of docs are 3. And then how many times it appeared in those docs is like 1. That's why 3 by 1. And 3 by 1 will be giving you something like the 1.59. And if it has appeared for all the documents, let's 3 out of 3 documents, then it will be 3 divided by 3 and log of 3. Log of 3 by 3, which is log of 1, and log of 1 we already know is 0. So it will try to make it 0. That means doesn't make any sense to count this word again and again. So that is term frequency, inverse document frequency. And word to vector, why we are doing word to vector? Word to vector means nothing but this kind of columns we are trying to create, right? For each and every word, I am trying to create a column, and for that column, I am trying to give this kind of weightages, guys. And on the basis of this number and weightages, I will try to make a sum or addition, right? If I am giving for positive words, I am giving somewhere between 0.5 to plus infinity, and then for negative, I am giving less than 0.5 minus to minus infinity, this kind of scales. And when I'm trying to sum them all, then I'll try to understand whether this sum of positive comes in more or sum of negative comes in more. And on the basis of that, I will be able to classify the things. Okay. Hope this understands and why we are doing this. Hope this makes it clear, guys, that what is word to vector, what is the inverse document frequency, and word to vector, whatever concept you are seeing, like bigram, n-gram, and all, right? Bigram, n-gram, they're just trying to understand the term frequency. That's it. They're either taking term frequency by dividing it in single, let's say in single group, or they're trying to make a groups, 2 groups, 3 groups, 4 groups, right? 4 groups. In this case, let's say this is an example this way, or they're trying to skip one word. This is, they will try to skip this and they will take this and then they will take an example, right? Then they will try to skip one word and try to take it. Then still end of the day, they're just looking at the frequency, that how many times, number of times this entire word is appearing. Okay, that's it. But they're not trying to penalize everything. That's why this TF-IDF coming into the picture. This is very important topic. And basis of this TF-IDF and verb vectorization only, we will be able to classify the emotions. I hope that, guys, now this makes you guys sufficient explanation for your questions. So let me switch back to new notebook, where we'll be doing a very, very beautiful use case for sentiment analysis. Right. Guys, you are able to see my notebook, right? Adi Purisha notebook. Just quickly confirm so I can go ahead and start explaining the things. Okay, all right, guys. So let's do this amazing thing. Now we'll try to understand. Let me tell you what will bring entire concept or entire life cycle. I will try to tell you within small, within one diagram. What is our main aim here is we are having tweets. Okay, this movie is released. Adi Purush movie is released, and the people are doing tweets regarding the same, right? Everyone is doing tweets. So first thing what we done is we collected these tweets, the data of tweets, okay, from Twitter. And now don't ask me how this is collected. This is using some sort of API and web scraping. Okay, using the web scraping, we're able to collect the entire data, right? Once this data is created, now what is our main aim? To perform the text pre-processing. Text pre-processing, right? I have to do a text pre-processing, like same thing, perform a sentence tokenization or word tokenization. Once we do sentence or word tokenization, then I will be able to remove the stop words, punctuation marks. Maybe in Twitter, we will be having some sort of special characters, some sort of, let's say, very weird emojis and something, all that, right? We have to clean that stuff, right? Then once we clean the entire thing and we do all the necessary things, or maybe it's very interesting, guys, to understand. Yeah, guys, my colleague will be sharing the attendance link. Don't worry. Okay. So very interesting thing to understand is that whenever we're trying to understand these tweets, right, and this giving you example option to tweet in multiple languages. Some people are tweeting in English, some people are tweeting in regional languages, and some people are using a third way, that is English, right? Some word in Hindi, some word in English, right? Could be possible. Or someone is writing a comment in Kannada, but he's trying to put these comments in English, right? Usually we do, right? We write in Kannada language only, or let's say we we try to type the things in for the Hindi only, but we're typing in English, right? We try to type in English, but the entire word when you're doing like okay, whatever we are typing, it is making sense only in the Hindi, right? So this kind of challenges you will be getting now, right? So you have to understand that if people are whenever tweeting, they're not tweeting in simple format. They're tweeting either in English or either in regional languages. They may be tweeting into a format which is a mixture of all the languages, right? And then what you will do? How will you be able to understand these things, or whether my model will be able to understand this kind of things, or whether my corpus consists of or this NLTK or Spacey library, right? Whichever we are using, whether it will be able to understand English, right? English, or for that reason Tamilish or anything, right? Whatever you call Kannada, Telugu, right? This is a challenge, guys, you will be facing. Again, the way people are writing is very weird, very weird. Okay, so you will be able to understand these things. You have to clean the things. And again, the next challenge what you will face is very, very super important. That whatever model or whatever things you are trying to understand, it is entirely a new concept. You cannot have a any pre-trained model over here. Cannot have any pre-trained model, right? Cannot have any pre-trained model because this kind of concept, right? Even just to have a pre-trained model, you should have a labels, right? Labels, that whether it is a positive comment or whether it is a negative comment, right? You don't have a labels, you just have a raw data, right? You need to have a some sort of annotation, right? Some sort of annotation where using which you will be able to perform the labeling, right? Perform the labeling on this kind of stuff. So this makes us very challenging job to convert all these tweets into the desired format, which can be consumed by our machine learning algorithm. And since we are going to perform it with the machine learning algorithm, so we'll be using the machine learning algorithm in order to perform the sentiment analysis. So without wasting time, let's get started. Okay, guys. So what I will be doing is, we have just scraped this file, adipurush tweet.csv file, and we'll try to bring that file within our data frame. Okay. So first thing is like importing Panda, Matplotlib, Seaborn. All these things will require to perform the manipulation, even to perform the visualization and all these things, right? And this second thing is to ignore the warning. And then I'm trying to read a CSV file, adipurush tweet.csv. This file contains all my tweet information, right? And then when I'm trying to punch this DF, right, or data frame, this is how it will look like, guys. Okay, it will have an only simple this kind of columns now. Okay. Date created, which consists of again a timestamp. It's a timestamp which consists of the date and time, date and time, right? Then number of likes, then source of Twitter. Okay, yes, no, or some none values, and then entire tweet, right? Whatever tweet is there, that text. Let's say England versus Australia. See, look at the comments, guys. Now you will realize how difficult this one is to bring it into the clean format. So what he's writing, what kind of comments he's writing? Hashtag Adipurush, then hashtag Australia versus English, Australia versus English, Australia versus English. What is this? How my model will be able to understand this, right? It is not what kind of language is this even, right? Have a look at this second sentence, right? He is writing all these Pepsi, Cola, movie, theater icons. Then now he's saying now playing, right? Now playing means this guy must be watching the movie at that time he tweeted, right? Now playing, book your tickets now, now playing, right? Then again, look at the third sentence. At the rate, O'Neill, what is this? Lemova, right? Adipurush. Now look at this fourth one now. Same things. Try to understand. This was the classic example I was talking about, right? Good morning Friday, Vastav mein Adipurush Yani, right? Yan means he is writing Hindi, he is writing English, even using hashtags and all other things. And even for Adipurush first week box office collection, right? This kind of tweets. Now about Ramayana, great epic. But this is okay. At least you are trying to write in English is okay. But he is writing in Hindi, some in English, and even he is using English, right? Somewhere. That's the challenge, guys. That's the challenge we have to meet. And this is the real-time example, how you will be able to deal with this data and how you have to clean the data. Okay, guys, try to understand that how we will be able to deal with this one. And now tell me, guys, if you guys are already having this background and you would like to tell me that what is the challenge now with this data, but how we, even if I clean this kind of data, how I will be able to fit this data to my model? Can anyone tell me the way? So what is the biggest challenge over here, which I already discussed a couple of minutes back, that what is the biggest challenge and how I will be able to tackle that challenge. I want to understand that is there anything which is coming to your mind, guys? Because this is only these 4 columns I am and I'm ended with, right? Language detection, correct. Language detection is the one thing. Okay, so that I have to understand, but try and understand that whenever I am trying to set any machine learning model, right? Any machine learning model, I need to have a target column, right? Or any column which having labels, class labels, correct, ma'am. Yes, class labels, but nothing that sort of exists, right? How I will be able to fit it to a statistical model y equal to mx plus c for that reason, or how I will be able to classify these models, right? If I am having this kind of data, right? How I will be able to classify this, or how I will be able to understand if this data is there and this is how the data is looks like, how I will be able to perform the distance calculation. That's the main thing, right? Mixing of language, also symbols, irrelevant words are challenges, correct, guys? That's the real challenge, that how I am able to convert this to fit this data into the modeling, right? That is the biggest challenge. My models are there, all the implementation is there in the scikit-learn, right? In scikit-learn, I can understand that I can take any classification algorithm or anything, and I will be able to perform a classification, and I will be able to tell you this is whether this is positive or negative comment. But in order to establish the pattern, I don't have any basis as of now, right? For this one. Now, first thing what I have to do, I have to clean the data, and after cleaning the data, right? After cleaning the data, I have to create the labels. That is my biggest challenge. Okay, labels. So then once I create these labels, then only I will be able to, yeah, guys, correct. You can apply clustering algorithm as well, but how it is gonna actually help you? If you apply clustering algorithm, still you will be able to apply the classification on it, right? And even once you do a clustering as well, still you require labels in order to understand the things. So it makes it more challenging, right? So once you are able to get the labels, then only you will be able to fill a ML model in it, and then you will be able to get a predictions. All right. So we have a very, let's say 40 minutes. So let's make a maximum use of it and try to understand how interesting it is to convert them. Try to understand the things. Okay. First thing, obviously, all the EDA part you will be doing. So I'm trying to understand that how many comments are there. Let's say I have 10,000 tweets and then 4 columns, and these are the name of my columns. It created number of likes, source of tweets, and everything. So let's start first with removing the duplicates values. So I'm trying to understand how many duplicate rows are there. There's only one row, so which is again fortunate enough that we are having only one duplicate row. So we'll try to remove them. So next thing will be to understand how many null values are there, right? Source of tweet, right? Look at this column, source of tweet. It is missing. All values are not there present. So it doesn't make any sense for me to understand the source of tweet. So I'm going to remove that, drop this source of tweet. Now I left with only 3 columns: date created, number of likes, and tweet. Now try to understand that. I will try to look at the different functions or objects and their data types of these columns. Okay, df of info, and then I'll be able to understand how many null values are there and what is the data type. So both of them are showing, like this date column is showing object. That means it's trying to show it as an characters, right? So I need to convert them into the dates. And also by using describe, I will be able to look at a 5-point summary, like what is my maximum value, mean value, median value, and all my quartiles and percentage, right? That I will be able to look at it. Then what I'm trying to understand is in the number of likes column. Okay, this number of likes, I need to understand what are the unique values, number of likes, date created, number of likes, and then for tweets. I want to understand that how many unique rows are there, right? Even for this remaining columns, I need to understand how many unique rows are there. Out of 10,000, these many unique rows are there. Then I'll try to sort the data and try to look at the headings, right? So look at the heading, guys. It's very interesting because when I looked at this way, I was not able to understand the number of likes and all this stuff, right? It was spread across. So I tried to make it in different way, that I'm trying to sort it by number of likes. And then by using the number of likes, why I'm doing this? Because I want to understand that whatever comment, whatever tweet is hitting high number of likes, maybe that is important, right? That will be able to help us to understand the entire sentiments behind this one, right? Look how Adi Purush Nirmato ko log ek aur jhatka. what is this? So by using this sentence, right? If I am trying to read this one, Adi Purush Nirmataon ko laga ek aur jhatka, I will not be able to understand whether this is positive or this is negative, right? This is neutral one. So now I understood that I have to make three bifurcations now. Not only positive, negative, I have to also consider the neutral category also, and I will have to clarify the things using the neutral. And even for this kind of comments, it is getting like 7,000 hits, right? 7,000 likes. Try to understand. And then Telugu version hits like 100 crore shares. That okay, it's good. It is hitting 100 crore shares means sometimes some scale is saying that it is like on positive side. People are liking it, right? Can't we convert to Hindi to English? Yeah, guys, that we'll try to understand that how we can convert and all these things. Let's go hold on your horses for the moment. We'll go step by step. We'll try to understand what could go wrong and what we can do about it, right? So just Quran par lage galan tattvon ke कारण छोटी सी document. See, again, this is very, what you can say is, you can consider this as hate speech. Some sort of, let's say, irrelevance, because we don't want to engage in any kind of illegal or illegal which can create a chaos, right? We don't want to create any chaos out of this one, so we'll try to ignore also this kind of things. So this is real time, right? Try to understand how difficult this one, because we are trying to understand the real time data. Now we are trying to understand how to perform emotion analysis on it, right? So now next thing will be to convert this date column into date of time, and then even after converting we can remove even time separately and date separately. Okay, so that's what they are trying to do. And then why we are trying to create as a date, because once you are able to convert it to date, then you can look at the data date wise, that how it is performing day by day analysis, right? Day by day, how it is hitting, what kind of likes it is hitting, what comment it is hitting, right? For that reason, just for solely for the visualization purpose, they are trying to convert this to date and time column. I will guide, guys, I will try to move quickly whenever there is a visualization, because it is self-explanatory and doesn't require any kind of explanation, right? Just by using plt.figure and plt.plot, they are trying to plot this data of date created, number of likes, right? So you can see that how the number of likes are looking like that. And on the day of January, sorry, not January, on June 26th, 2023, they are hitting very high likes, like around 14,000 likes, right, over the time. So this is way on other days, it was like around 8,000 maximum, right, on the scale of the 8,000. But on this particular June 26th, it was able to hit the highest one. So this could be one of the way that whatever tweet is there or whatever tweet are done on this day, right, they are very important, which will help us to analyze the emotions. So that's how I can again say. Again, I'm trying to plot a scatter plot and try to understand the things. What are the other lines in visuals? Which lines, guys? Okay, these guys. Okay. It is nothing but they are trying to show like number of likes, right? And within that number of likes, they are trying to showcase. What they have done is like they're trying to showcase on the basis of the some beans, maybe, right? On the beans, and they're trying to showcase on the basis of the likes and dislikes over the time. That's why. Okay. Again, look at the date and then try to show the comments, right? These are the data points, guys, which are available on that particular day, and these are different tweets, and for the tweets, they are trying to show the different count, right? For that reason, you are seeing multiple values. Okay. Now coming to our main pre-processing part, right? I understand this is very important. I'm trying to import the regular expression. Regular expression, we already know we can convert the string data. I mean, manipulate the string data. We're trying to import the strings and date and time parser, date util parser, and data and time. Okay, and TDM. This is very important. Understand what is TQDM. TQDM is nothing but whenever I am trying to perform any task, right? Whenever I'm trying to perform, I'm trying to show a progress bar like this one, called as progress bar. If I want to show progress bar, this progress bar will be showing me, let's say, if I have a 10,000 iteration, out of that 10,000 iteration, at what level I am currently there, right? Whenever you see a training data, at that time you see 10,000 out of 10,500 are completed, right? This kind of statistics, whenever you try, let's say 10,000 completed out of 10,000, and this progress bar will be shown like this one, right? In this case, it will be moving further. Whenever you want to create this kind of progress bar, that library is called as TQDM. Okay. For that purpose, we are trying to showcase this library. Then we are trying to understand what is the spell checker, because using spell checker also we'll be able to analyze. Now, main question, like I told you, right, how to create the labels. For that purpose, we are having this kind of functionality which is already available in NLTK.sentiment.weather, right? In that, I am trying to import this sentiment intensity analyzer as SIA. Okay, try to understand. Don't try to rush the things. I'll try to make you understand one by one that how we are trying to apply the things. But try to understand, just to create the labels, we'll be using sentiment intensity analyzer. Okay. Word cloud, I will try to tell you what is word cloud. Whenever we trying to plot this kind of graph, this graph will be shown like words. That word like good, superb, and this word is like this is a graph of the entire words only, and these words are capitalized or shown with the broader width, right? So whatever having higher intensity, those words will be highlighted, right, within that text. So that kind of graph is created using this word cloud and image color generator. And stopwords you already know, and I'm trying to import the random function out of it, right? Let's understand that. That first thing what I will be doing is like removing the stopwords. Now stopwords.field, and then whatever supported languages are there, right? I'm trying to fit the supported languages and the count of these languages. So in that languages, whatever stopwords are available, and what are the stopwords and what are the languages available for that. So in total, they are supporting 29 languages. These are the languages which they are supporting. Now, what is interesting for me here is to look at the thing which gives me a kind of relief is they are supporting English. This makes my job very easy, right? This language model, analytical model, this is supporting English, means whatever tweets are there, right? Which are like half Hindi and half English. I don't have to do a manual job converting them to English. Maybe English it can understand, right? It understand the English, so Hebrew also. So sometimes whenever we don't understand anything, we already let's say we already usually popularly we say that don't speak in Hebrew, right? I don't understand. So even they included this Hebrew language. So what for my purpose of importance is this one, English, because it will be able to understand the mixture of Hindi and English both, right? And it is supporting that one. So this makes my job very easy. Then I'm trying to import the tokenizer and stopwords in English as well as in English, right? That's why I'm trying to bring them. And then again, the same thing we'll be doing to remove the stopwords and remove the punctuation marks, right? Over here. Example of English. Yes, guys, we'll try to see the example of English when going forward, okay? So first, what I have to do is, if you look at the data, our data also contains this kind of words, right? HTTPS, @ hashtag, right? This kind of tweets, right? So tweet is nothing but same thing, whatever we have done, right? This column, this tweets column, right? So I have to clean this for that purpose. And now I'm trying to do one by one, right? One by one. First, I will try to regular expression sub, and then in regular expression, if this kind of things are there, please remove them. Also, this kind of things, right? Colon, exclamatory mark, backslash, W slash, or something like that, right? Then once I remove them, then I'm trying to do a tokenization. Tokenization for the preserve, whether to preserve a class, all these parameters. Don't worry about this parameter, reduce strength and everything. Then just I'm trying to tokenize the words. Once I tokenize the words, right? Difference between text blob and better according to you. Okay, guys, text blob is again a different library in better. I will try to speak about it, okay, in tomorrow's session. What is the difference and everything? I will try to tell you. Okay, try to understand the. We need to finish this one, right? This thing. So I will try to focus more on this, and tomorrow I'll try to speak about this. I'll take a note of this text blob and better library. I'd like to tell you what is the difference. All right. Then what we have to do is once we tokenize this tweet, right? Tokenizer dot tokenize tweet. So once we tokenize, then I'm trying to pass the stopwords, right? These tokens for the stopwords for token, right? For token in token, if not in English words or not in English words, right? Then I am trying to save them. Then removing the punctuation marks and convert to lowercase. Also, very good example. that we seen that yesterday we spoke about why we are not able to remove stopwords, right? What is reduced length? Guys, don't try to focus on this as of now. Reduced length is like sometimes I'll tell you this concept. This is again advanced concept. Okay, so you can use this kind of parameters and try to make a changes whenever you're trying to do a tokenization, right? So as of now, you understand that this is some sort of way how we can use a tokenization, right? A preserve case means sometimes whenever you try to tokenize the things, it is trying to preserve the uppercase, lowercase, or how whether it will be able to remove any length out of it, that kind of things, right? That all these parameters are there, but for understanding now, it is very important that we understand we need to tokenize the things. Don't worry about it. You'll come to know whenever you try to execute this kind of code. You can try and play with this kind of parameters, and you will be able to understand. That's not that difficult. Okay. So what we are doing is first now we are importing English and English stop words. Also, this kind of punctuation marks we created, and this kind of other special characters, and we need to remove them, and also we need to make a switch to the cases, right? Where we are trying to take it as a lower case. Then I'll be ending with the clean tweet, and then I'll try to punch the clean tweet, apply the clean on in that data frame. This is the function which I have created, def clean tweet. And then I'm trying to call this function and try to apply this, right? By using apply function, you can apply any function, right? You can apply any mathematical process on this entire data frame. That's what we're trying to do. Apply this clean tweet function, which I have created here. And then it will be able to clean us, right? Now I'm trying to show you the clean tweet. This is the next column which I have added to my data frame, because I purposefully want to keep a previous one, and I want to show you that how the cleaned tweet will look like, right? So if you see this one, English, and all Adi Purush, then it is converted to this kind of things, right? So now playing book your tickets, it is converted to now playing all these characters are removed, right? This one, this is again just example, guys. I'm not run these things. Otherwise, you will be able to see the entire course. So I'm not trying to run this one. That's why sometimes you will be able to see the only half of the results, okay, over here. So don't worry about it. When you try to run on your own, you'll be getting entire sentences. So just trying to understand that whatever tweet was there, we were able to successfully clean it. That's the whole purpose behind this exercise, right? So then again, it has removed, see, it has removed the hashtags. It has removed some other words, right? It has even, if you look at this case, this was on uppercase. Now it is brought down to lowercase. Some stop words are removed. Guys, you have to feed, yes, feed the, you guys have to fill the feedback form. Then only your attendance will be taken into consideration, guys. Okay. So whatever link is given in the chat box for the feedback, you just have to fill, and that's how you will be able to get your attendance marked, right? To understand this one also, hashtag is removed, lowercase is taken, right? This is how we are able to convert the things. Now next thing will be to further apply more clean text, right? Clean text on the data frame, and then try to do some kind of splitting, right, for the tokens. This is lowercase. Then after doing the lowercase, I'm trying to remove this, right? Strip. Then try to apply the things using the lambda function like clean text on the clean tweets, right? Then next step is to perform the lemmatizer, wordnet lemmatizer, right? So we already seen this thing. So I'm just trying to download the lemmatizer, and I'm trying to create a function. This is called as lemmatizer. And by applying this function, we'll be able to make a lemmatization on the entire things, right? And they are creating one more thing. Once I create a lemmatization, I'm trying to apply this on the clean tweets, right? We have got clean tweets. Now I'm trying to apply this on column. Then it will try to bring it to the basic form, looking at its meaning also. Then I'm trying to remove the digits also, which are present in the tweets, because that digit doesn't make any sense for me, right? For that purpose also, I'm writing one more function, remove digit, and I'm trying to pass that regular expression, and whatever regular expression are present, that will be removed, right? Clean text. Then again, I will try to apply this one, the same, remove text and perform the lemmatization. Then next task will be to understand or detect the language, right? Yeah, guys, it is already, this attendance link is already shared by my colleague Omar. Then you can refer to common chat box. Now we're trying to understand that what are languages are present, and we'll try to make a column for that one. Okay. For that purpose, I am trying to write this function. def detect language try and accept block. I'm trying to write it like language equal to detect language. I have created this function. We're trying to import this function which is already present in NLTK. That is language detect, import detect, and detect. I am trying to pass this text. Whatever text is there, that will be able to provide as the language, right? And then I will try to apply this detect language function on my language column, right? This language column I'm trying to create, and I am trying to apply this on the clean tweets detect language, and then whatever language it detects as per this library, I will showing be into this separate column, and this how it will look like that. If you have seen this one, now we have created two columns. First one, the clean data against our old tweets, clean tweets, and then language column we are added, and we will be able to see what kind of languages it is able to detect, right? It is already interesting for us to understand that how it is try to create, right? So it is try to understand this. See this one. Hindi, English, SV language, right? This is none because it is not making any sense at the rate Adipurush hashtag, right? So that's why it is giving none. And this kind of things again it is trying to understand. Okay. So we were able to successfully understand what is the language present. Then what we can do is once I understand that English tweets, right? Whatever languages are present, I can even furthermore go ahead and create one more column called as English tweets, because it will be interesting for me to reduce the data if I only try to analyze on. It's up to us because guys, it is nothing mandatory that you will be only analyzing the tweets. If you want to analyze the entire overall sentiment, it's okay. But we'll try to understand what if the English tweet says, right? For that purpose also, they are trying to create a column and just passing the symbol that language equal to English, then that will be shown over here in the columns, right? This will one more column called as English tweets, which will be showing only tweets in the English, and whatever the tweet is not in English, it will be showing you NaN values for that reason. Okay. Then again, whatever values which are not in English, we'll try to drop them. So by using drop NA. Okay. Yeah, don't worry, guys. We will wait for the attendance and everything. We will be able to do it, right? So let's finish this one. Once I remove this, then again I am trying to create a column called as year, month, and day, and then I will try to analyze the data using this one, right? So date created, whatever this date is there, and I am trying to use the function called as dt.year, dt.month, and dt.day. By using this function, using the pandas function, right, you will be able to create a separate column called as month, year, and day. And this how it will look like. What month was there, what day was there. Now it will help us to analyze even day-wise data. Then we try to look at the unique values now. Then dt.time, date created, and tweet length. Now I want to also understand that what is the length of the tweet, right, for that particular date. So for that purpose, I am just providing str.length function, and I will try to create this kind of let's say column, right, where I will be able to see the time, dt.date time and date length, right. We have created only month, day and year, but I did not create a time value. That's why I'm trying to create this over here. Time equal to dt.time for the same column, date column, which was originally there, right, in the original 4 columns. It is there. By using that column only, we try to create the by forget the date by using this kind of function. And I also want to understand that how big is my tweet, right? The length of the tweets and how many tweets were done on that particular day. That's also interesting for me to see. And then when I am able to plot this data, I will be able to see that within the month of June, from date 23 to date 30th, what was the day and when was the most tweets were performed, right? And you can say on 24th, around 1200 tweets were done. And for other days, it was around 6,000 to 8,000 tweets done, right? So I can understand that whatever emotion is there on 24 could be also interesting, right? So again, I'm trying to plot the same thing using the visual graphs by the plot. Then I'm trying to plot a histogram for the same. And then the box plot. Again, guys, this is very important because we are doing all the EDAs over here, even for the sentiment analysis, right? That's why I'm trying to plot the different things over here. I could have ended up directly one graph and I could have finished and then applied a model. That could have been an easy part, right? But that's not how the things works in the real, right? I can directly use one visualization, maybe a bar plot or something like that. and then I could have applied my model, right? Once I get the labels. But for till now, even I have not created any labels as well, right? I just trying to clean the data only. As of now, I just removed the stop words. I detected the language. I was able to look at the length of the tweets. Whether this not in English, then I removed all these things which are not in English. I removed the duplicate values. I created a multiple columns, different columns, right? By using date and time to perform the more visualization, right? So this is how the things will be working. What box plot indicates for NLP task? Yeah, correct. Again, the same thing, guys. For the box plot, I will be able to see that is there any outliers present. Same thing I will be able to see, right? Because I am trying to see that. Look at the length of the tweets, right? This particular length of the tweets. If you are trying to perform this data on the length of the tweet, I can see that there are some outliers values are present. There maybe it is a good intention for me to consider this kind of outliers. Even it is not mandatory, okay? But just for the more analysis, I am trying to understand that what kind of tweets are there, what is the normal range of the tweets for any particular day, right? This you can even looking at that, let's say bar graph also you will be able to understand. But still, you need to understand that how you can perform more depth analysis, how you will be able to understand the feature engine. For that reason, we are trying to do it, guys. If you have any question, please ping me in the chat box. Okay, I will try to take it simultaneously. Now, by using box plot, I was said that on this is one particular data which is present, which is far away from the mean, and then it could be a point for me to understand, right? Now, try to understand, guys, that what we have to do is now we have to create the label. This is very important task, guys. Please try to focus now. So till now, what I have done is I just clean the data, but I did not create any labels for the data, right? I told you that we'll be using the this particular function, right? Since I could remember, I will go back and try to show you. Sentiment Intensity Analyzer, SIA, right? Try to focus on this one now. Sentiment Intensity Analyzer, okay? This is the function called as SIA, Sentiment Intensity Analyzer. Now I am going to use it to create the labels for our data, right? Trying to understand how I am trying to create a labels for them. Okay. So I just created a simple function which is called as label sentiment, and I am trying to pass a value out of that. If that value, okay, that value, let's say that will be like internal function which is already created and trained, right? So to be able to understand the sentiments, that's why we are using this sentiment intensity analysis. On basis of the intensity, or try to calculate a probability on it. On basis of this intensity, it will try to create a probability, and if that intensity is like with very, let's say within less than minus 0.5, we'll term it as negative, and it is if it is more than 0.35, we'll turn it as positive. Otherwise, if it is not matching, we'll try to create as a neutral, because we have seen that certain sentiments are also neutral. They are falling in positive, negative categories. So this way, I'll be able to create a different kind of three labels, whether it is positive, whether negative, or whether neutral, and it is based on the intensity, guys. Try to understand. Okay. So what I will do is I am just calling that function, and then on the sentiments and the overall sentiment, this kind of two columns I will be creating, and on the basis of that, it's not showing message. Yeah, don't worry, it will show. Okay, and then I told you TQDM to show you like how it is able to perform this kind of scores, right? The SIA polarity scores, the SIA function sentiment intensity analysis, and then I'm trying to apply that function on the English tweets, right? So this SIA dot probability scores, then I'm trying to apply for X in DF dot English score. So one by one, it will try to go through it, and then try to apply the scores for it. Then overall scores or sentiments will be seen, right? And once I am able to see the scores, this one line is for creating the scores, guys. And on the basis of that scores, I'll be giving in the second line the labels, right? So that's why on the basis of this condition, 0.05 less than minus 0.05 and will be negative, and 0.35 will be positive. For that purpose, I have to apply for scores, and once I get the score, then I will be able to create apply the labels, right? So this is the two way how it will work, this sentiment intensity analysis, right? And then this is a progress bar which will take some time, like it will be showing you progress this way, that whether it is trying to go through all these tweets and what is the progress. For that reason, we are using PQDM, right? So again, guys, once I am able to apply this and I'm able to get a score and overall sentiment, let's try to understand how it looks like. Now I think it is visible, right? So everyone is able to see this one. So now we have created year, month, day, time column, length of the tweets, right? And then now two columns we have added using SIA function, right? Sentiment analysis function. One is we created the score, and after that score on the basis of that conditioning less than minus 0.05 or greater than 0.35, we are giving positive or negative score, or otherwise it is neutral. So that's how you can see the score. It is showing neutral. The scale neutral, right? Neutral. Now it is more than 0.35. It is showing positive. Okay, that's how. This is the two columns which we require, right? Otherwise, by going manually and try to annotate all the things would have been very difficult task. So thank God to this NLTK SIA function, which will be able to create a score, and on the basis of the scores, on basis of the intensity only, guys, try to understand. So it will be able to give us the labels as well, right? So this is how I have created now labels. Now, once I create a label, then my task becomes simple, that I can choose this model, right? I can even go ahead and further perform some kind of feature engineering on it. I try to see what else I can do with this data, and then only I will be able to apply my machine learning models, right? So let's quickly go through it and try to understand what they have done now. Now they have seen that once I able to create this label, they try to look at the values, that what are the unique values for all these three categories, right? So you can see that we are having neutral, more number of neutral comments, tweets, negative comments followed by negative comments, and then we are having very less positive comments, right? Try to visualize them, right? So we can analyze that, okay, people have given more neutral comments and followed by the negative comments. Then now you will get a sense, you will be able to get a sense of this sentiment, that what direction these sentiments or tweets are going, right? But still it is not the end of the story. Still we have to analyze or perform the machine learning modeling on it, right? So I'm trying to look at the same thing, whatever graph I have seen, I'm trying to make a pie chart out of it, right? And then it will become more vivid, that how my bifurcation is for the entire tweets, right? So I can see only 25% of the data is showing positive feedback. Neutral feedback is like around 39%, because it's 38.9, and then around 35% people are saying it is a negative, right? So this makes it's now it is started making a sense that how my this sentiment could have been, right? So what I can do is, yeah, guys, attendance link is already shared. Okay. Now what I'm trying to do is, I'm trying to create a different graph, different data frame, whatever data frame was there, DF, I try to create a copy of it, and then I'll try to apply the different things on it, right? We already see now what we have done. So just for the purpose of the experimentation, they are trying to create a two different graphs. Okay, guys, you can fill in, okay, whatever attendance you have missed. They're trying to create a different simple, let's say two data frames, and then on that basis, you will be able to understand that what is the attendance. Okay. Okay, guys, my colleague will be sharing it again, okay? Amar will be sharing it, so you guys will be getting the link of the attendance. All right, guys. So what we're trying to do is, we are not interested in English tweets as of now, and we want to understand that what is the overall sentiment for it, right? So I just created a sub data frame out of it. I just took the two columns, English tweet and overall sentiment, and then I'm trying to clean it. Okay, English sentiment overall clean, and then I am trying to clean even further, that if there are any this kind of words is there, right? The sign is there, right? So by using this one, I am trying to make them into lowercase, and if there is any other white spaces are there, right? Any spaces are there in the comments, all the spaces will be also removed using the regular expression plus sign dot strip. Okay, and then also try to split, okay, whatever words are there, I try to split these words, and then I'm trying to rejoin them, and then I will be calling them as a clean English words, right? This way. This is already done in regular expression. Yes, very good. but we are whatever regular expression we done, guys, this notebook will be shared in the LMS. Okay, this regular expression, whatever we done, was done on the basis of the entire tweets, not on separate English tweets. Now we are doing it for the separate English tweets, guys. Right? Try to understand. Whatever we did was on overall tweets. Now we have filtered these English tweets, and then we are trying to make it cleaning, right? So that's how clean English tweet. And then once we get this clean English tweet, right? No, guys, don't need to follow entire process. What process we have done? Like we are just trying to remove. We've seen that even before, still trying to understand, guys, what has done and why we are trying to perform this 2 times. Then there was like overall tweet. On overall tweet, we did the cleaning. It consists of all the languages like English, or some other language was detected, right? So we even did on that entire data set, right? But still, when we trying to consider only English to it, right? Only English language at that time, there will be when I try to look at the data, there will be certain specific rules, specific regular expression rules, right? Regular expression rules I can apply, or I can apply some sort of cleaning, right? Where there are white spaces available, white spaces available, or whether there are any other expressions available, like let's say there is only initial word is capitalized in, let's say amazing, only initial word is capitalized, or some sort of things are there which are only relevant for the particular English language library, right? So that kind of cleaning we are doing now. We are not doing entire steps again. Okay, so that's what they have done here. Yeah, guys, this is how you have to do. There's some efforts you will have to take. Okay, in order to perform it or make it more clean, right? All right, guys, link is already shared. Don't worry about it. So we also saw that non-meaningful words were there also, right? Whenever you try to analyze these things, so they are come across the non-meaningful words because CR, AMP, rupees, UNL, right? This kind of words were there. Again, they are trying to remove this word from the English because this was not done previously when we tried to do cleaning, right? So we are now looking at the words and then try to significantly try to look at the words which are only English speed words, and then we try to apply if any further level of the cleaning is required, right? So once I am able to do that, then I will try to visualize that what are my important words, or what are the words that is coming very frequently, right? Very frequently, and I'll try to create this kind of weight cloud graphics, which consider all the words, and whatever words are coming very frequently, those are capitalized, right? So you can see using this code, weight cloud equal to max cloud and width and height, and we have to provide, and then generate this kind of show and plt.show. You have to provide this tweet data, clean English tweet data, right? And in clean English tweet data, you can see that these are the words which are coming very frequently. That means these words has an high importance, right? This has an high importance. That's how they're coming very important, and this will help us in perform the sentiment analysis. Now they are taking like bifurcating positive, negative, and then I'm trying to take the weight cloud and then try to understand how it looks like, right? Then guys, very important step. Now we are able to achieve our entire clean data, right? Then I will be able to apply a model on it, right? So what I'm trying to do is from SQL, I'm trying to import trend test split. Now, whatever data is there, now till now we have done only cleaning, text pre-processing. Okay, text pre-processing is done. Now whatever my 100% data is remaining out of this clean data, now I am trying to split them into train and test. So for this purpose, I am trying to do a splitting in terms of the, let's say 80-20 or 70-25, right? That kind of splitting I will be doing, and then on top of it, I will be applying. But movie word make any importance in cloud can be removed. Yeah, guys, don't worry. It will be taken care. It will be taken care by our model, right? So you don't have to do what is the use if you're trying to do each and everything, right? So once we are able to split it, right, then we are using count vectorizer. And then after using, sir, can we please share this? Yes, guys, we will be sharing this Jupyter notebook is for you guys only. Okay. So let me quickly proceed to this one. Count vectorizer, and then we try to fit the count vectorizer. Then we trying to transform these values, right? Stop words, English, Ngram, minimum difference, max difference, and this kind of vector TF. Then you can perform this kind of words. Guys, some things I have given purposefully. Whenever you're trying to do a vectorization at that time, you can have this kind of intent or permutation or combination also, where you can perform n-gram, script-gram, minimum difference and all values, right? But guys, whatever you guys have missed, that will not be shared again. Okay, whatever present days link is there, it will be shared. Or you can send an email. You can send an email. LMS access is already shown, guys. Go back and watch the lecture, previous lecture. Okay, try to we guys are already running late. We just require a couple of minutes, then maybe I will try to give you a time to give me a question answer session, right? Okay, you can ask at that time. So let us finish this model, right? First, we understood that we have to perform a TF-IDF, right? Once we perform the TF-IDF, then I will be able to create a word vectorization, right? So for that purpose, I am trying to import TF-IDF and then trying to pass this TF-IDF from the train data. So create a IDF transformer dot fit xtrain, then whatever transform data is there, right? Then that data will be now further used for our modeling, right? Text and target. Now we are trying to split in text and target. What is my target? Overall sentiment. That means positive, negative, neutral, and then my other features, right? Whatever other columns are there. That columns, okay. And then don't worry. This is again this one is like how you perform the word embedding, right? Using the deep learning techniques that we'll discuss more in detail when I will try to cover the recurrent neural network. Just for the advanced word embedding purpose, I have already included this code over here, right? So main aim is to this is the main aim, guys. Main is to fit the model. Now what we're trying to do is, once I perform the TF-IDF and trying to transform these values by using TF-IDF, I will be converting entire my text data into the numericals, right? Using TF-IDF. This is what I have done, right? In previous cases, TF-IDF, right? Now, once it is converted, then only I will be able to fit a model. Once I perform this TF-IDF transformation, then I'll be using this TF-IDF to fit my model. For modeling purpose, what I am trying to do is I am calling multinomial NB. Guys, understand what is multinomial NB is? This is a naive Bayes. This is a naive Bayes model. Naive Bayes model. I am trying to calculate what is naive Bayes model is probability of A provided B is given by probability of B by A. Here probability of B into probability of A. So this is how the formula looks for naive Bayes, and that by using naive Bayes, why it is called as naive Bayes, everyone knows that it has a basic assumption. This is assumption that all the columns are independent. All columns are independent of each other. That is the basic assumption. So in text, right? In text data, we can already say that one text is not affecting other text, right? Even for the purpose of the meaning, it is affecting, but every word is different, right? So that's how this model perfectly fits in. And why we are taking multinomial? Because we are having more than 2 classes, right? For that purpose, we are taking multinomial. Otherwise, would have took the Gaussian NB model, right? Gaussian NB model. Once I am able to take the Gaussian NB model and then try to pass using the NB.fit train data and Y train and X train. This is my features and this is my overall sentiment. Y train is my overall sentiment, which is having 3 categories like positive, negative, and neutral, right? Neutral. So all these 3 categories which will be consisting row by row, and I will be able to fit a model out of it, right? Once I fit a model, then I'm trying to predict and then look at the accuracy, guys. So we are able to achieve a 71% accuracy, right? Okay, guys, thanks. But try to understand, okay? Try to understand. I know it is a bit rush, like we are trying to do. And once we are able to perform this kind of things, right, we will be able to classify the model and be able to predict. Like, okay, once I am able to perform this kind of model, right? And then whenever the new tweet comes in, now my model training is complete. Whenever new tweet comes in, I can directly take that tweet and pass through that model.predict NB model, right? multinomial MNB model, and then I will be able to say whether it is positive or negative trick, right? This is how. This is the certain other things I have given, guys. Pipeline, okay. These are certain other things which are advanced concept, right? Over using the pipeline. What do you mean pipeline? Pipeline means you have to take the data and you can apply multiple function at a time. That is called as pipeline. In this, what we're trying to do is we are taking a pipeline, then we're trying to do a bag of word model by using word vectorization purpose. Then we are using TF-IDF, and then we are trying to fit a model. So all these three operations we are trying to do on X-train and Y-train. For that purpose, in order to make this working, we have to call the pipelines. Okay, that is the function of the pipeline. By using pipeline, this is one of the method, guys. Yeah, guys, it's like, so if you want to perform all these operations, right? See, if I don't call the pipeline, what will happen is you have to perform these operations separately on the data. By using pipeline, you can apply these operations directly. Pipeline is just like the pipeline where you're inputting the data, extract data, and you're trying to perform this kind of operation, bag of words, TF-IDF, and then fitting a model, right? Fitting a model, and you will get a final prediction. That's what they're trying to do. That's called as pipeline. Okay. Try to understand they're using pipeline.fit. See, what I am doing is here, if you look at the model, I have fitted a model here, right? In this line, I was able to fit the model. And before that, I was able to do a tokenization. Even before the tokenization, I did a TF-IDF, right? So I did three different operation for that purpose. If I want to apply all this operation at once, so I can create using the pipelines, right? By using the pipelines, I am trying to say that apply all these function at a time. But so I have created this pipeline, let's say variable, and then I am trying to call it all these three functions using the pipe, right? Pipe function, and then I am trying to fit the data X-train, Y-train, and once I fit, it will be internally calculating the bag of what TF-IDF. Whatever TF-IDF is calculated, it will be fitting into a multinomial Gauss-based model, and then it will be give you the predictions, right? Pipe.predict. So this is how the real-time functioning works, guys. We don't have to create multiple line of code. So that's why people use this kind of pipelines, and it is because just to make a code more efficient and proper structured manner. So we are calling pipeline, and then we are trying to apply different operations. Then your model will be ready, and again it is going to give you a decent accuracy of 70%, right? All right, guys. Just I know it's already late, so just I'll try to finish this remaining things. Then whatever multinomial Gauss-based model we have fitted, even you can fit a different model. Let's say in this case, we are trying to fit a XGBoost classifier, and then again we'll try to check what is the accuracy. So we are able to improve accuracy by 1%, 71. Okay. So this way we understood that we can apply a multinomial Gauss-based model. Also, we using a technique and ensembling technique, which is called as XGBoost classifier, right? This is the one ensembling technique. In this XGBoost classifier, also you have to mention what model you will be using, and on the basis of that classifier, XGBoost classifier, we are using the tree only as a tree, and then parameters we are trying to pass, and then try to achieve whether we are able to achieve these things, right? Yeah, guys, that will be taken care in the pipeline whenever you try to find. If you are trying to provide that model, right? Parameters also. You can provide these parameters over here in this bracket using the pipeline. Okay. At that time, we can provide the parameters over here. Okay, guys. So that's how I think this is it for the movies, right? And we are able to see that we applied to one technique. We used like a simple model. Then we used a ensembling technique, using which we created the number of trees, and on the basis of the trees, we're trying to predict the things. I am sure that this code is not that difficult, right? We just trying to pass these things, and then number of estimator we are taken like 80 trees. We are taken like number of estimator 80 minutes. We are taken 80 trees, and we are following an ensembling technique. By using the 80 decision trees, we now try to predict, right? And on the basis of that, we are able to achieve the 71% accuracy. That's it, guys. I think this is how the real time it will work. Then we will just have to. Yes, guys, I'll be sharing this entire notebook in the LMS, so you will have it for your reference. Okay. So in the last steps, once you do this, then maybe you have to save this model using .pickle or some other model, and then you have to expose this to API. And by then it will become a like functional app where you will be able to do a movie sentiment analysis. Okay, movie sentiment analysis. That will be the last steps we'll be doing. Then end-to-end application will be also done. Data set I don't have, guys, with me. Yes, data set I am having CSV file. So I will try to share it with you. Don't worry. Data set I already having. With file data set already having this one CSV file. Okay. I hope, guys, you enjoyed this entire code walkthrough, right? I know it was a bit like somewhat rush, but I think that was self-explanatory. Most of the topics were self-explanatory. Most part we did is using the, yeah, guys. Okay, thank you. Okay. So most of the part was the EDA, and then how we clean the data, and then we were able to fit the model, right? So that's how. And the main challenge was like we did not have the even what you can say, we did not have the labels. So how we created labels. Okay, these are the 5 major things. Okay, that's how you will be able to do it, right? All right, guys. I hope you enjoyed this one. And then thank you very much. I know already taken a 10 minutes extra, but it is important that we finish this thing. So tomorrow I will try to give you a simple walkthrough for the same project, engineering feedbacks, engineering college feedback for the course sentiment analysis. And then I will not take the entire code walkthrough. Within 5 to 10 minutes, I will finish this one. And this will be assignment for you guys to, you have to perform these things, right, in your class. So tomorrow, most probably we'll try to start with the recurrent neural network. LS and using the recurrent neural network and LS team will try to fit a one deep learning model to perform the fake news classification. Okay, that will be the agenda for the coming days. And then we'll try to move to next things again, always in the ladder like we discussed in the first day. All right, guys, thank you very much. Then we can conclude our session for the today. I hope you enjoyed it, and see you tomorrow for the further topics then. That's it, guys, from my side. If you have any question, do ask me. Otherwise, we can go ahead and close the session. Thanks, ma'am. Thanks for the compliment. We'll wait for a couple of minutes, guys. 1 or 2 minutes more, not more than that. If you feel and you need to ask any question, ping me quickly. Otherwise, I will finish this session then. For today, we can conclude this session. I know it was a heavy thing to digest, but this is how the real-time work look like. Okay. All right. All right, guys. Any questions quickly? I know it's already 10 minutes late. We need to finish this. All right. All right. What is the loss function TF-IDF? As TF-IDF, just the word to vector embeddation, there will be no loss function. Loss function will be for our algorithm, whatever algorithm you are using. Let's say multinomial Gauss base or whatever XGBoost classifier we are used in, that will be having the loss function. Just by using TF-IDF, we are trying to create a matrix word-to-word message. Can give a small talk for how to retrieve the tweets from Twitter. That's a difficult part. Even I will be struggling for that one, but I'll try to look at how people have created this one, these tweets, because these tweets has to be done from the APIs, right? Twitter has the API. Okay, Twitter has the API. I can show you how to do a web scraping, that I know. But for tweeting, for collecting these tweets, there is a one API, Twitter API. By using this Twitter API, you will be doing a web scraping. That is not a small process. Okay, for web scraping, usually we take like 1 or 2 sessions, entire 2 sessions discussed. API creation, yes, guys. API creation is, you should know the API creation, right? So until unless you create a API, how your model will be consumed, right? Whatever now we have created this kind of beautiful model, which can be generalized for any movies, right? You just punch in the tweets there, it will be able to clean all the tasks, and it will be able to give you review, right? Whether it is positive or negative. This is generalized now, right? This kind of tweets will be coming most probably. So you can use it, generalize this for any movie now. Any movie which is giving us a tweets, as long as we are able to collect the tweets. Okay. So you'll have to create API. Otherwise, how the people will be able to consume this one model, right? Anything else, guys? Any other questions? All right. I know it's already late. Thank you very much, guys. So we'll try to even continue this discussion in tomorrow's lectures. I'll try to dedicate some time, especially for the question and answer. No, guys, Hugging Face as of now, no, it was like too much then to fit in into the 1 week's data. Hugging Face and everything, Hugging Face platform and everything. I'll try to go with the small platforms like using the Colab and using the Jupyter Notebook itself or using deep learning libraries also. Okay, Hugging Face will take some time to understand or get the feeling or get the gist of the Hugging Face and everything. All right, guys. I think that's most of it today. We can conclude the session. Thank you very much, guys, and good day ahead. And see you tomorrow. Okay. Yeah, over from my side, Amar. If anyone would like to add any comment, then go ahead. Otherwise, we can close the meeting.
Yeah, sure. Thank you so much. So guys, if you have any query or question for me, please drop in the chat box. And one more thing, I already shared the attendance link. So please mark your attendance and share your valuable feedback as well. I'm sharing that link again in the chat box. If anybody is remaining, please mark your attendance. Yesterday class was not there. No, there is no any class on yesterday.
Yeah, okay. Yesterday, okay, you guys are asking literally for yesterday. So yesterday was holiday, so we did not do any session, guys. Okay. So don't worry about yesterday's session. All right, guys, then thank you very much. See you tomorrow, Amar.